So we are now going to do construction of images in convex lens by ray diagrams. So I'm going to show you one case, that is when the object is placed beyond twice f1. Now first step, you have to draw the convex lens. So I'm drawing a convex lens using a protractor. You do like that. Okay, or you can use a compass. Then after that, after you finish to draw the convex lens, then you will find the optical center. So how do you find the optical center? You measure the length of the lens like this. So here I'm getting 7 centimeters. Okay, so the optical center will be at the middle point. So that means if this is 7 centimeters, then the optical center will be at 3.5. So here at 3.5, I mark like this. Then I'm writing optical center O. Then after that, you will draw the principal axis passing through the optical center. So you have the principal axis. Next, you will draw the radius of curvature. Okay, so how do you measure the radius? It is from O to C2 or O to C1. So you have to decide how much you want to take the radius of curvature. So I'm taking 4 centimeters. So O to C1, I'm measuring 4 centimeters. Also O to C2, 4 centimeters. Okay, and then this gives you the radius of curvature. So keep in mind, you take either 4 or 6, but even number, it will be better, easier later on to divide it into 2 equal parts. So you have here OC1, OC2. But keep in mind, we never write C1, C2. Instead, we used to write twice F1 for C1 and twice F2 for C2. Okay, so we write twice F1 for C1 and twice F2 for C2. Keep that in mind. Next step, we will find the focus F1 and F2, the first and the second principal focus. So how do you find that? Since from O to twice F1 is 4 centimeters, so half of that will be the focus F1. Here also, that means at 2 centimeters, you will have the principal focus F1 and here F2. So always equal length. OF1, if it is 2 centimeters, OF2 also should be 2 centimeters. So OF1 I have chosen 2 centimeters. So OF2 also should be 2 centimeters. Okay. Then, so that is the first step. You draw the lens, the optical center, principal axis, measure F1, F2, twice F1, twice F2. You are asked to put the object beyond twice F1. Beyond means behind. So I'm going to place the object anywhere but behind the twice F1. And at the same time, keep in mind, you measure the height of the object also. So I'm taking 1 centimeters height of the object. So that is the object placing behind twice F1. The next, I will apply the rule. Rule 1, what it says, rule 1. Rule 1 says that the ray which is parallel to the principal axis. So I have to draw a ray, incident ray, which is parallel to the principal axis. This is the principal axis. This is the principal axis. So this ray is parallel to the principal axis. When it passes through the lens, okay, it suffers refraction. And keep in mind, when you draw this incident ray, you have to draw till this line. This line is the joint where these two surfaces are joined. So this gives you that joint, that point where they are joined. So the ray will enter till this point, and from this point, refraction will take place. So we have to draw till here. Then from there, refraction take place. So when it enters the lens, it passes through the lens, it will suffer refraction, and then it will pass through F2. So like that. So that is rule 1. Parallel ray after refraction passes through F2. Passes through F2. Rule 1. Then now I will combine with rule 3. Rule 3 says that when a ray of light is passing through the optical center. So here optical center is O. So if you draw a ray of light passing through O, it does not suffer refraction. It will just go straight. So you draw like this, it goes straight. Okay, so no refraction take place, it just goes straight. So if you look carefully, these two rays, this one and this one, all right, they meet at this point. So this point where they meet is the position of the image, and this image is formed below the principal axis. So therefore we say that the image is what? Inverted image. So keep in mind, when the image is formed below the principal axis, the image is inverted. That's why I'm putting this arrowhead also upside down. Inverted means upside down. So that is how we draw the ray diagram. Also write in the conclusion, when the object is placed beyond twice F1, the image form is what? Number one, image form is what? Position. That means you have to find where is the image form. Look carefully, you'll find that this image is formed between F2 and twice F2. So the image is formed between F2 and twice F2. So this gives you the position of the image. Next, the nature. Nature means what type of an image. So here it is, real and inverted. Real and inverted. Keep in mind, inverted image is upside down image. So this gives you the nature. How do you know it is inverted? Because it is formed below the principal axis. Next step, next one, we'll find the size. The size, look at the object size and the image size. By looking also you can make out which one is bigger, which one is smaller. So here we have seen that the image size is very small compared to the object. So I am writing diminish image. That means very small image compared to the object. So that is how we have to write. Now I'm going to show you one more how to draw the ray diagram, and I'll take this case when the object is placed between the optical center and the first principal focus. That means when the object is placed between O and F1. Okay, now we are going to draw a convex lens. This time I can also do like this to draw a convex lens. I will first measure the length of the lens. Okay, so I will take 6. All right, 6, then you draw like that. That also can be done. So this is 6, that is the middle line of the lens. Then with the protector you can join like this. Okay, then you'll find that your lens become straight also. Okay, like that. So this gives you the lens of 6 centimeter. And now you find the midpoint of this lens. Okay, so at 3. So that middle point will be your optical center. Then from there the principal axis will pass through the optical center. Okay, then again the same way you measure the twice F1, twice F2. Again I'm going to choose 4 centimeters. Okay, here you'll have twice F1. Then this side also 4 centimeters. You have twice F2. So twice F1. Here twice F2. Then half of this you will get the first principal focus F1. And here also 2 centimeters you measure, again F2. position of second principal focus. Next, you are asked to place the object between the optical center and the first principal focus. That means you have to place the object between O and F1. Again, this time I will again choose the height of the object 1 centimeter. So like that. All right. Then now you will use the rule. Rule 1 again. Rule 1 says parallel ray of light which is parallel to the principal axis. This ray is parallel to the principal axis. Till this line, keep in mind, you draw the ray till this line. From that point, diffraction will take place. Then after it enters the lens, refraction take place, and then it comes out and pass through the focus F2. So this is rule 1. Parallel ray, parallel to principal axis. After refraction, it passes through F2. Then again, I will use rule 3. Rule 3 says ray of light passing through the optical center, it goes straight. No refraction, no bending take place. So it goes straight like that. So no bending, no refraction. It goes straight. Okay. So you see these two rays do not meet. Even if I continue, okay, backward, still they will not meet. So what I do, I will put a ruler like this, straight, like this. See that it should be in straight line like that. Then produce the side using dotted lines. Okay. Then this one also put nicely like this, straight, like this. And then draw dotted lines like this. So you'll find that, see here, at this point, they meet. Okay. They meet at a point. So this gives you the position of the image. So here you have the image. And where is the image now formed? The image is formed above the principal axis. So the image is above the principal axis. That's why it is an erect image. That's why I'm putting this arrowhead upward. It is an erect image. It is also a virtual image. So how we write the conclusion? So we write when the object is placed between O and F1, the image form is what? Position first. Where it is formed? See here, it is formed on the same side. The object is this side, to the left side of the optical center. Okay, object is to the left side of the optical center. Image also is formed to the left side of the optical center. So we say the image is formed where? Where? On the same side as the object. Same side as the object. So this gives you the position. Then next, the nature. What type of image? Erect and virtual. Erect and virtual. Okay, or you can say virtual and erect also, no problem. Okay, so erect image because it is formed above the principal axis. Third, size. Look at the size. This is the object, this is the image. By looking only you can make out, okay, that the image size is very large, bigger than the object. So I will write enlarged image. Enlarge image. So that is how we do the ray diagram. Okay.